Exercise 1.3, sum number 1 to 5. So we are going to see 4 sums today. One sum is left as homework. Right, the topic is functions. Functions you learnt in 10th standard. The same what we are going to learn here also, the functions and its types with some explanations, some more explanations, a few more explanations, right? Right. Now first we'll see what is the function, the definition and the types. A function is a relation. You know what is a relation? So it is a relation in which each element in the domain is mapped to exactly one element in the range. Okay. So first to see X is the domain, Y we can say as codomain, right? Now it is given that each element in the domain, that is A, B and C, must be mapped to exactly one element. So A is mapped with X, B is mapped with Y, but C is not at all mapped with any element in the Y. So it is not a function. In second image, A is mapped with X, B is mapped with two elements, not one element. It is given exactly one element, but B is mapped with two different elements, so it is also not a function. So finally, here A is mapped with X, B is mapped with Y. So all the elements in the domain is mapped to exactly one element in the codomain or in the range, so it is a function. Now types of functions. Injective, you learnt as one to one, isn't it? So injective means every element in the domain must be mapped with a single element in the codomain. So codomain also, that means the element in the codomain also should be mapped with only one time. Okay, that means this A is mapped with X, B is mapped with Y. So it is a one-to-one connection. A is connected to X, B is connected to Y, mapped with Y. Okay, suppose this Y is mapped with any more element, means it is not one-to-one. Okay, so this is called as one-to-one function or injective function. Then we have surjective. Surjective means we have to check from the codomain. All the elements in the codomain must have a pre-image. Okay, X and Y are the images. So X has an image, pre-image A, Y has two pre-images B and C. So it is a onto function. Now you check here, this is not a one-to-one function because A is connected with X, it's a one-to-one connection, but B is connected with Y, C is also connected with Y, so it is not a one-to-one function, it is an onto function. Now bijective, both one-to-one and onto. So we have to check two conditions. Okay, A is connected with A, B is connected with B, C is connected with C, which is a one-to-one connection. Coming to the onto connection, A is mapped with A, B is mapped with B, C is mapped with C. It means all the elements in the codomain X is mapped with the domain X. So it is a bijective function and neither one-to-one nor onto function. So why? The reason is, now check here, his B is mapped with Y, C is also mapped with Y, so it is not one-to-one. And in the codomain Y, Z has no pre-image, so it is not a onto function, so it is neither one-to-one nor onto function. Right, so now we have seen all the types. So now we are getting into the exercise. So exercise 1.3 we are going to see. In exercise 1.3 I am going to teach only 4 problems and one more problem, that is the second sum, is left as homework for you. So you have to do it as homework, right? Now see sum number 1. Suppose that 120 students are studying in 4 sections. Okay, see where A denotes a set of students. Okay, so this is A denotes the set of 120 students. B denotes the set of sections. So this is B, so set of 4 sections A, B, C, D. We have to define a relation A to B, X related to Y if student X belongs to the section Y. So it means all the students in the set A is mapped with set B. So all the students is connected with any one of the section in the set B. So we can say that this is a function because each student is studying exactly one section. That is, suppose a roll number 1 means he is studying only in section A. He cannot study in B or C or D. So it is an exactly one map. So it is a function. Now second question is, can we say about what we can say about the inverse relation, the reverse, that keeping the section as domain and the student set as codomain. Now we have to check in a reverse. So which is not a function. See, A is mapped with more than one element in the set, the section A. From the set B is mapped with more than one element in the set A, which is not a function. What is the definition for function? In a function, every element in the domain must map with exactly one element in the range. But here it is not like that. So the reverse is not a function. Reason is each section includes more than one student. So it is not a function. Sum number 3, write the values of f at different values are given. So this sum is also known to you very well. Right, I'll explain. Now first we will check about the first value, which is -3. So -3 comes in the interval, that is open interval of -infinity, 0. So I have to take the first function, right? So coming to the first function, f of x is equal to x square plus x minus 5. And here I have to substitute -3. So in the place of x I have to substitute -3. So -3 the whole square is 9. -3 minus 5. So 9 minus 8 is 1. Second one is 5. So 5 is a positive number. This comes in the second interval, that is open interval of 3, infinity. So I have to take the second function, which is x square plus 3x minus 2. So in the place of x I have to substitute 5. So 5 square is 25 plus 3 into 5 is 15 minus 2. So 25 plus 15 is 40. 40 minus 2 is 38. Now coming to the third one, which is 2. Now this is very important. Now see here this interval is open interval of 0, 2. It means greater than 0 and less than 2. It is not 2. Here 2 is not included. So we have to check for any other interval. So no other interval states anything about 2. So we have to go for only otherwise. Otherwise means the value is not included in the interval. We can take this otherwise and you can use this function. So for 2 I am going to use only this function, which is x square minus 3. So in the place of x I have to substitute 2. So 2 square is 4 minus 3, which is 1. Then we have minus 1. So minus 1, this also lies in the first interval, which is -infinity, 0. So in the place of x I have to substitute -1. So -1 square is 1, -1 and -5. -1 and +1 cancel. So the answer is -5. Then we have the last one is 0. So 0 lies in the interval. We have to check the same problem comes here. Here it is 0 here and here 0 is mentioned. But the problem is here it is the close, that ending value is 0. That means -infinity less than 0. Here it is greater than 0 up to, that means less than 2. So in both the places they didn't say about 0. It is less than 0 and here it is greater than 0. And again we have to go for otherwise function. So x square minus 3. So which is 0 minus 3, which is equal to -3. Now sum number 4, state whether the following relations are functions or not. First we have to say whether it is a function or not. Suppose if it is a function, we have to check whether it is one-to-one function or on-to function. If it is not a function, we have to tell what is the reason. So now it is given set A has A, B, C. So this is set A, B, C. Now A to A is a function. So another set is also, that is the codomain is also A. So A is mapped with C. So A is mapped with C. Here B is mapped with C. So B is mapped with C. C is mapped with B. So C is mapped with B. What is the first condition? Every element in the domain must map with exactly one element. Okay, so A is exactly mapped with 1, B is exactly mapped with 1, C is exactly mapped with 1. So it is a function first of all. Then we have to check for 1 to 1. 1 to 1 means it's a 1 to 1 mapping. Here A to C 1 to 1 mapping, and B to C is also mapped with C. So A to C and B to C is not a 1 to 1 mapping because C is mapped with 2 elements. So here it is not 1 to 1 function. And now coming to the onto checking. Onto means all the elements in the codomain must have a image. So A doesn't have an image, so it is not a onto function. So it is neither 1 to 1 nor onto. Subdivision 2, here x comma y comma z, it is a set. Here is this x to x mapping, the function x comma y comma z, and here also x comma y comma z. Now x is mapped with y, okay, x is mapped with z, and z is mapped with x. Here we have to check. So here the two condition fails. Now see here, x is mapped with y and also x is mapped with z, which is not a function. Function clearly says that each element must map with only one element, exactly one element in the range. So this is not a function. And also y doesn't have any mapping, so it is not a function. Now the last problem, set A is given 1, 2, 3, 4. Set B is given A, B, C, D. Give a function from A to B. We have to form a function A to B, which is using the 4 subdivisions. Okay. Now first of all, what is given is neither 1 to 1 nor onto. Okay. Neither 1 to 1 nor onto. Now see here, I mapped 1 with A and 2 also with A. So here it 1 to 1 is failed, isn't it? So it is neither 1 to 1. So it's supposed not to be onto. So I have left one element D without mapping. So 1 to 1 is also failed and onto is also failed. So this is neither 1 to nor onto. So this is one form. You can also make few more mapping of your own. Even in the book back answer is also different from what I have done. Okay. Right now subdivision 2. Right, we'll finish the answer. That is 1 comma A, 2 comma A, 3 comma B, and 4 comma C. Now subdivision 2 says that not 1 to 1 but onto. So first it's supposed not to be a 1 to 1 function, but it should be a onto function. So to do that, see, first it's supposed not to be a 1 to 1 function means, so I mapped with A, B, C and D. Suppose this connection, if I suppose not to make a 1 to 1 means this 4 to D connection can be changed as 4 to C connection. But if I make a 4 to C connection, 1 to 1 is success, but D doesn't have any pre-image, so onto fails. So we cannot make it. So if it is 1 to, if it is exactly onto also, we cannot make 1 to without onto or onto without 1 to here in this particular thing. So it is not possible. So third subdivision also not possible, because if you make 1 to, it is clearly onto. So if you make a onto, clearly it is 1 to. So here it is also not impossible. Now coming to the fourth subdivision, both 1 to and 2. So this is the exact form of 1 to and onto. So it is 1 comma A, 2 comma B, 3 comma C and 4 comma D. So that's all of today's class. Do the homework. That's all. Thank you.